A major magnitude 7.7 earthquake earlier today struck Indonesia, causing significant damage and generating a tsunami. Yet, before I explain the specifics of this earthquake, I want to let everyone know that this earthquake occurred in an unusual spot, and this makes it scientifically interesting to talk about. This earthquake specifically struck north of the island of Flores, with an epicenter about 68 kilometers or 42 miles west-northwest of the city of End. Striking at shallow depths at 5:58 a.m. local time in the morning, a more than 200-kilometer-long segment of a major fault line slipped to accommodate regional stress, uplifting water in the overlying ocean and generating intense seismic waves. The ground then subsequently shook back and forth for 52 seconds, causing some buildings to partially or fully collapse. This was the exact same magnitude as the deadly 1992 Flores earthquake, and since today's earthquake occurred at even shallower depths and also damaged a few local volcano observatories, I feared the worst. Yet, despite preliminary models showing a large amount of fault motion transferring to the ocean floor, no towering tsunami similar in size to the 1992 one was generated, instead only peaking in height at 2 meters. This was probably owed to a lack of major submarine landslides this time around. It also helps that locals are better aware of tsunami hazards and what to do after a large earthquake strikes if they live near sea level. So, tsunami casualties should be low. Damage from the earthquake itself also seemed to have been less extensive too, probably because this magnitude 7.7 earthquake occurred much further offshore, leading to less intense peak ground motion. Regardless, this is a major disaster, with preliminary USGS estimates of between 100 and 1,000 fatalities and $100 million to $1 billion in damages most likely. So, why do I call this earthquake scientifically interesting? Well, the plate boundary south of the island of Flores is well known, involving the Indo-Australian and Sunda plates, which can produce megathrust earthquakes. This earthquake occurred in a different megathrust zone north of the island. Yes, Flores has a plate boundary to both its north and south, but there's a catch, and it gets weirder. The northern plate boundary involves a segment of the Sunda plate colliding with and beginning to subduct underneath, also the Sunda plate. You see, due to the ongoing tectonic collision south of Timor, the rate of motion in the Sunda plate segment consisting of Flores Island is slower than the motion to its north. Since these are both moving southwards, it causes compression to build up, and this created the beginnings of a new subduction zone. Whether this counts as a new tectonic plate is up for debate, as each geologist seemingly has their own slightly different interpretation of the global tectonic plate map. But if it is a tectonic plate, then it involves the beginnings of subduction of the Banda C plate underneath the Timor plate. Regardless of which interpretation is correct, the overlying tectonic plate segment gained increasing compressional stresses due to the motion of the subducting other plate, also causing it to deform downwards. This occurred until a critical point was reached, causing a major earthquake which made a section of the overlying tectonic plate snap back upwards via what is known as a megathrust earthquake, in this case by up to 2.6 meters or 8.5 feet. Now, the MMI contours I have shown in this video are based off of the most recent USGS model of the event. Despite me willingly showing it, in my scientific opinion, I think the current updated model is somewhat incorrect, specifically because I really do not think the rupture trended slightly to the west-southwest, as if anything the rupture should have trended slightly west-northwest or just straight west. I also think the MMI contours below MMI 5 are a bit too large. I say this because current on-the-ground data in my opinion seems to somewhat disagree with modeled results. The strongest ground motion was about MMI 9 in some highly specific spots, with this description accurately describing what type of damage would be expected there. However, a much wider area experienced MMI 7 and MMI 8 damage. Now, while landslides and liquefaction were modeled to have occurred, there is also a very negligible chance that the earthquake could have theoretically caused a change at one or more regional volcanoes if they were already primed to erupt. Thankfully, no obvious changes have yet been observed at any regional volcanoes. And finally, here are the approximate number of various magnitude aftershocks modeled as being statistically most likely to happen.